Okay. It's a cloudy season. I'm not sure how well this stream is going to go, but let's see. Mm, okay, so welcome back to um, the daily data structures and algorithm stream. Okay, so today I'd like to go over certain things. Um, I brought back the Google Docs, yeah, this shit again. So this is what I'm going to cover today. I would, go over this question I solved yesterday, and also um, do some revision, right? Um, yeah. So here's everything we need to cover. I'll need to cover today. Then I would. So I was going through the binary search list today, and I found out the two sum question was also part of the this list. And the took some question initially was supposed to be how do you call it, a two pointer question. And also apparently you can use binary search to solve this, which I had done already, so I'll explain how to do that as well. And yeah, so let's kickstart. Oh, yeah, so there is another question, which is the zigzag conversion. And this question was so annoying. Like I had to like beat my head around to actually even understand the solution to begin with. Yeah. So the question did not say much, but I'll try and explain that as well. Okay, so let's get started. Let's get started. So where do I begin? All right, so let's begin. Uh, I don't know if I should solve the questions or before I revise. I go over the revision. Which one should I do first? Let's see. Oh, I need to increase my time. So let's increase the time to. I think I'll be able to cover an hour today. So let's go to 60 minutes or 65. Yes, 65 minutes, which is an hour and 5 minutes. Okay, so let's get started. First of all, I'll let me just cover this question again. I explained it, but yesterday my explanation wasn't really good at all. So, apologies for that. And so I'll just come back here again. Right. I'm just going to use this for the explanation. And okay. So, this is a binary search question. It's search a 2D matrix. You are given an m by n integer matrix, right? With the following properties, with the following two properties, sorry. Each row is sorted in non-decreasing order, which also means in increasing order. I don't know why they try to do this, which is very annoying. Anyway, the first integer of each row is greater than the last integer of the previous row, right? Given an integer target, return true if target is in the matrix, or false otherwise, right? If it's not in the matrix, you must use a log m times n time complexity. So here is our matrix, right? And we are going to search within this matrix for a value which is our target. Now in this case the target is 3, right? So we look inside this matrix and we get 3 and then return true, right? Since 3 is part of this matrix. Otherwise, if 3 wasn't here, we would have returned false, right? The same thing will happen here as well. Now the good thing about this is there are two ways we can actually solve this question. One way is to treat each row in the matrix as each column in the matrix as a single entity to perform a binary search on. Here's what I mean by that. So each row in the matrix is an array, right? Let me turn on my okay. So here, this row here, right? This is a single row. Now this row here is an array. Now we can perform a binary search on this row, right? So let's say this matrix here, right, encapsulate every row. So we have three rows in this matrix, right? So this is going to be row 0, row 1, and row 2, right? This is 3 rows. Now we can perform a binary search on each of these rows, right? So to look for our targets, which is simply going to be equal to t, right? Let me quickly remove everything else. So we are going to perform a binary search on this row, which is the first row, the row at index 0, then row at index 1, and row at index 2. Now we are going to, the reason why we are performing the binary search on each row is to look for our target, right? Is to look for our target here. So our target t is going to be equal to 3 in this case, right? We are looking for t in the 3 in this case. So when we perform the binary search is going to be such that we are searching within halves of the array, right? So let's say in this case we have 1, 3, 5, and 7. Now a typical way, a simple method, right, but not very efficient, to look for an item in an array is to iterate through each item, or iterate through the array, traverse the entire array, and look for a value at a particular index and compare it to our target t, which is equal to 3 here, right? When we do things that way, we'll have an operation which is going to be of a log O of n time complexity, right? Because we need to traverse the entire array. If our target was at this point here, if 3 was at this point, or let's say our target t was at this point, then we'll have to traverse the beginning towards the end of the array to look for that item, right? But since we are going to use a binary search, we will no longer need to traverse the from the beginning of the array towards the end, but we'll do it in a way that we first of all divide the array into 2, or in other words, get the middle value of this array and compare it to our target, right? When we compare it to the target, we can either come to a conclusion, or we can either find out that the value at the midpoint, or the middle value in this array is either going to be superior to the target or less than the target, right? So let me put it this way: the value, I'll say mid value, the mid value is either going to be superior to the target or less than, it's going to be, yes, superior to the target or less than the target, like this. Now when in the case where the middle point is superior to the target, which is this condition here, it means we'll have to shift our middle point towards the right, And the reason why we need to do that is because we know the array is sorted in non-decreasing order, like they said, or in other words, in increasing order. So which means the smaller values are on the left and the higher values are on the right. So if we found a midpoint that is bigger than the target, then we'll have to look towards the right, because we want our target, we want our midpoint to be closer to the target, right? So which means if the midpoint here, right, let's say we calculate and the midpoint is 3, right? So let's say midpoint is at index, midpoint is equal to 1, right? And the value at 1 is equal to 3 here, right? This value here. So meaning if our target was supposed to be 1, right, which is this value here, then we have to move our midpoint towards the left. Otherwise, where the target is somewhere, let's say the target was 7, right, this value here, right, our midpoint has to be shifted towards this point here. Now, in order for us to shift the midpoint around, we need 2 pointers. We need a left and right pointer, right? So our left and right pointer will point at each end of the array, and it is with those 2 pointers we will use to find the midpoint, right? So let me show you how to do that. So we will need the left pointer here and the right pointer at this position. Now, when we are performing the calculation for the midpoint, we simply need to take the left plus the right, divide this by 2. Now we want to do the division so that we get a value closer to 0, or in other words, we just round the value to the nearest zero value. So and for a simple way for us to do this in Python is to use the double division operator, right? And then when we perform this division, so let's say this is at index 0, this is 1, this is 2, this is 3. So when we do 0 plus 3, right, divided by 2 this way, this would have given us 1.5, but since we are rounding it up, we'll get 1. So which will represent our midpoint, right? Our midpoint is this. Now we'll have to find the value at this midpoint here. So let's say the array is x, right? Our array is x, or let me call this row 1, since we are looking inside this matrix, right? So I'll say r0, right, which is the first row at index 0. So we will perform a binary search on this row, right, separately. Now when we perform this binary search, we'll get this midpoint. First of all, we always use the midpoint to find a particular value in the array, right? So which is our target. So our target here is t is equal to 3. So we found our midpoint. The midpoint here is equal to 1. So what is the value at midpoint? R0 at this midpoint here, right, is equal to what? Is equal to R0 at 1, right? R0 at 1 is simply the item at this position here, and this item here is equal to 3, right? This is equal to 3, and 3 is simply equal to our target, right? Our target, the target we are looking for is 3, and you can see how this is easy. We didn't need to perform, we didn't need to traverse the loop, the array from the beginning towards the point where we find the target, right? We simply need to find the midpoint each time. If 3 wasn't our target, right? If 3 wasn't our target, let me just remove this. So I'll say this 0 at 1, this is going to be equal to 1, sorry, this is going to be equal to 3, and 3 is equal to our target. If 3 wasn't our target, if we're looking for a different value, right, first of all, this midpoint would have been calculated. We would have had 3 as our value. We'll compare it to the target. Now if 3 wasn't our target, we'll calculate the midpoint again. But before we calculate the midpoint, we have to perform a check, all right? We have to check whether the current value at this midpoint is superior to our target. Let's say our target is maybe our new target, I'll change the color here. Our new target here is 7, right? We are looking for 7. Now how do we get 7? We'll move, since the value at this midpoint, the first midpoint we found was 3, right? We know 3 is less than the target, which is 7. 3 is less than 7. So meaning we have to move our left pointer. We have to move our left pointer towards a point where, towards the point where we found. We have to move our left pointer past the midpoint we found previously, right? So we have to move it past this 3 here. We have to move it towards this point here, which is at index 2, right? So we'll find the midpoint at this point here between these left and right pointers here. So that's how we will perform these calculations, and we'll do it over and over until we find we find our target. Now, in the case of this matrix, right, if we did not find our target in the first row, we'll perform the binary search on the second row and then on the third row. Otherwise, when we reach the third row, right, we'll return false if we don't find any value that is equal to our target, right? So this is how we'll perform these operations. Now, this is good, right? This works fine. In fact, I actually this was one of my first submissions. Let me show you. Okay, so this 3rd of June. Okay, so here, this was the first submission that I made, and you can see the runtime was okay. I'm not sure why the memory was this bad, and I don't even know if the memory was going to be better. But the point is the solution worked, right? You can see. So here is what I did. Sorry, let me show you my solution. So I performed this binary search on so here we go. Time complexity. Yes, so here is the solution. So I started with a loop, right, and I iterated over each row, right? I iterated over each row and then perform a binary search on each one of these rows, and found the target at a certain point. So when I found the target, I'll return true. Otherwise, I'll just return false, right? But another thing I did here was to first of all see if the target is within the range of the current row, right? Within the range, and by range I mean if the first value here, right? If the first value here is less than the target, less or equal to the target, and the last value here also, right, is superior or equal to the target, meaning there is a chance that the the target is within this this row. Otherwise, there's no need for us to perform the binary search on this row. So this is the solution. I did this on I'm not sure, like 2 days ago. Yes, so I solved this on 2 days ago. So you can check the solution in that video, right, in that recorded session, to see how I did it. But anyway, there is another way to do this, which is what the question is really asking us to do, right? So the question is actually asking us to solve this in O log m times n time, right? So how do we do this? Well, for us to solve this in that particular time complexity, right, we need to perform let me just remove all of this. So for us to solve this in O log m times n time complexity, we need to treat this array as a 1D array, or in other words, we need to treat this matrix as a 1D matrix. Currently, this matrix is a 2D matrix, right? A 2D matrix is simply an array within arrays, and a couple of arrays or one array within another array, right? We can have this is a 2D array, or in other words a matrix, right? Or if you had something like this, one array here, another array here, like this is also a matrix, right? Which is what this entire thing is, right? Which is what this entire thing is. And the M here, right? The M here represents the number of rows, right? The number of rows, right? This is 0, 1, 2. Or in other words, when you start counting from 1, this will be equal to 3. So we have 3 rows, right? And n is how many columns we have, right? N is going to be 1, 2, 3, 4, right? We'll have 4 columns in this entire matrix, right? So now, how do we treat this as a single 1D array, right? So to treat this as a 1D array, we need to point at each end, right? We need to take the entire array, the entire matrix, right, and put our left pointer at the beginning and the right pointer at the very end. Now, how do we get to the end here? We can see the beginning, which is this first row, and that the last item or the last end of this array will be at this position here. Now, for us to do this, we simply need to multiply. For us to get to this point, we simply need to multiply the number of columns we have by the number of rows, right? So this is 3 rows, right? 3 rows, and then this is 4 columns, right? So at this point, this position here will be equal to 12. Now let's count to see whether that is true. So this is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now you can see that is how we get the right pointer at this position here. So we simply multiply, we simply need to multiply the right pointer, the number of columns, right, or number of rows by number of columns. So n, we know m represents rows, and n is our columns, right? Columns like this. Now, how do we get the value at this particular point here? Now, certainly we can't say we have a value at index 12. That is not going to be possible, because we'll start counting from 1. From 0, right? So we'll start counting like this: 0, 1, 2, 3, 4, 5, 6, 7, right? 8, 9, 10, 11. So how do we get 11? We simply need to perform this calculation minus 1, right? Then we'll get the value or the index for our right pointer. Now, why do we need the left and right pointers to point at, each end of the matrix? I'll put this back. Now, we need to do this because we don't want to start looking through each row. We simply need to jump to a particular point. It could be somewhere, anywhere around this side, to get the target within this matrix quicker, right? So here is what we need to do. L is going to be equal to 0. The right pointer is going to be equal to 11. Now, when we find the midpoint, right, we simply need to do L plus R divided by 2, which is going to be equal to 11 divided by 2. It's going to be equal to 5.5. So we round it up. This is going to be 5. Now, 5 is the position, the midpoint in the entire matrix, right? In the entire matrix. And when we start counting, this is going to be 0, 1, 2, 3, 4, 5. Now we know our midpoint is here. Our first midpoint, when we calculated the midpoint, is going to be at this position here. So what do we do about this? Well, we first of all need to know in which row this midpoint is in order for us to access it, right? Because we can't say, our matrix here is going to be an array of arrays, right? An array of arrays like this. So we have three rows, which is this one here, 1, 2, and 3, right? I'll call this matrix M. Now we can't say M at 5, right? This is impossible. We don't have any value at this point here. We can have values within the arrays that will be up to 5, but in this case we only have 4 columns, which is also impossible. So how do we locate this midpoint on this entire matrix? Well, there is a calculation we need to perform after finding the midpoint in order for us to access the row, right? So for us to access the row where the 5th item is in the entire matrix, we simply need to divide this again by the entire length of the arrays or the columns that the matrix has. So let's say we need to just take the midpoint, right? In order for us to get the row, we just take the midpoint and we divide it by n, right? And we also round it up to the nearest 0 value. This is simply going to be equal to 5 divided by how many columns do we have, or how many items we have in the array, right? This is simply going to be equal to 1, 2, 3, 4, right? So this 3, right? We divide this into we divide this into the length of the array. So we divide it by the length of the array, which is 4, right? This is going to be 1 point something, but we need to round it up to the nearest 0 value, right? This is going to be equal to 1, right? This is simply going to be equal to 1. So 1, when we start counting the rows, right? Remember I said we start counting the rows from 0, 1 to 2, right? So where is 1, right? Where is row 1, or in other words, this value here that we just calculated? Row 1 is at this position here, right? Meaning our midpoint was found on the second row, right? On the second row. Now, how do we access the column at which this value is? Just by using the midpoint that we calculated. Well, we'll simply need to use the modulus operator. Now, we use modulus operator because this help us, how do I put it? The modulus operator was what we used to use. I used to use on circular arrays, right? In other words, if I had a value, let's say I had an array x, or let me say an array y equal to 1, 2, 3, right? And I want to access a value at position 4, right? At position 4, y at index 4. Now this is impossible, right? This is not possible. We can't access any value at index 4, because the last possible index we can access an item from in this y array is going to be at index 2, right? Because the last item in this array is at position 2 when we start counting from 0. So this is going to be 0, 1, and 2. So we can't access any item at index 4 or index 3, right? This is impossible. This is out of range. But there is a possibility for us to do this by just performing a simple calculation. So instead of using 4 directly, we perform a modulus operator. I mean, a modulo or modulus, I don't know, a modulo operator operation on this value, right? So we simply do this, divide this by the length of the array, right, which is going to be n, or in other words, this is going to be 3. Now this will return the remainder of the operation, right? When you do 4 divided by 3, right, when you do 4 divided by 3, you have 1 point something, right? So I mean, yes, when you do 4 divided by 3, you have 1 point something. So that will return the last item, right? So this is going to return, I'm not sure, 4 divided by 3, what's the remainder? 4 divided by 3, this is going to be 1.333333. But when you perform the modular operator on this, right, this is going to return 1. Let me quickly prove that here. So I'll say print, oh god, let me increase the screen, sorry. Okay, so let's print 4, 3, right? This is going to return 1, right? This is going to return 1. Let's see. Yeah, so this is 1, right? This is the remainder of the division of 3 by 4, right? So this is going to return 1, and we know item at index 1 is 2 here, right? No matter how high the value here is, right, or becomes, no matter how high this value becomes here, when you perform the modulo operator, dividing it by the length of the array, you will still go back, right? It will just return back a specific, a specific and real index in the array, or real value in that array. So here's what we need to do here, right? So after finding our our row, in order for us to access the column at which that value is, we'll simply need to do this, right? So we'll say, the column will be equal to the row where we found, this value here, right? The row. Then we'll still take the index, right, which is 5, modulus of the length of the array, and this will return 1 as well. So from the calculation, right, the row will be equal to 1, and the column will also be equal to 1, which is this value here. And that is how we are going to access the 11, right, which is our midpoint in the entire matrix here, this entire board, right? On this entire board, the middle value on this entire board is at this point here, which is 11, right? So that's how we'll find those values, right? Let me quickly erase everything, and then we continue performing our binary search. Now we know at position 11, right, this 11 here is superior to our target. We are looking for 3, right? We are looking for 3. So what we do is, since the value, this result, I'll call this res, right, because this is what we found, right, is superior to the target. Target is equal to 3, and the result we found here is 11. So since 11 is superior to 3, we move our right pointer towards the lower side, right, because we want to find a lower value. Now we don't move it here, we move it past that particular point, right? So now we are going to look within this range, right, or this column. So we are going to look within this part here. So from here all the way to this point here, this is what we are going to search in, instead of searching the entire matrix itself, right? So that's how we are going to do this, and this will simply help us, and we'll perform the same operation again by finding the row and then the column, right? So this will help us get this log m times n times complexity for our operation, right? And this is the solution for it. So when you can access the solution from how do you call it, from the GitHub repository. I have the link in the description, so yeah, you can have it there and use it. Okay, so let me check the comment section quickly. Oh, hello. Hi, Ransom is here. Nice to have you here again. This is really nice. Somebody said, what's going on, brother? Data structures and algorithm. That's what is happening here. All right, so let's move on to another topic, right? The next topic we'll look at is the let me remove this here. So our next topic will be on, what did I plan to do? So I solved these questions yesterday. LEETCODE search, insert, position. This is a binary search problem, right? This is a binary search problem, and so let me quickly open this. I'll just click on this, replace this with this title. Wait, let me see. Oh wow, that's nice. Wow, this is cool. I didn't even know I could do this. Wow. Okay, that's good. So let me open this link. So here is a problem I solved yesterday, which was a really nice problem, right? It's simply a binary search problem. And so the problem says, given a sorted array of distinct integers and the target value, return the index if the target is found. If not, return the index where it would be if it were inserted in order, right? You must write an algorithm O log of n runtime complexity. So this is quite similar to a normal binary search, but this time around there's a trick to it. Now, instead of returning true or false if the target existed in the array, we need to return the index at which, yes, we return the index at which we found the target. Otherwise, we return the index where the target would have been if it were inserted in the array. Now, so let's take a look at this, right? I'll just use this one here. This array here. It's 1 3 5 6. 1 3 5 6. So 1 3 5 6. I'll remove this completely. Let me remove this. Okay, fine. So we have an array. X is equal to 1 3 5 6, right? This is our array. Now we want to perform a binary search on this array to find. First of all, let's break this down, right? We perform a binary search. We want two things, right? We want to return. So we have a target 1 3 5 6. Our target is 2, right? T is equal to 2. Now we want to perform a binary search on this target. So first of all, number one, we want to return the the index of our targets, right? Index of targets. Or number two, we want to return the position where the target could have been in this array if it were inserted, right? So I'll say I'll call this prospects index. Prospect index. So yeah, okay. So this, I will not type it all. I'll just okay, let me just call this prop like this, right? So we'll find the index of the target in the array. Otherwise, we return the position where it would have been, right? Okay, instead of prop, right, let me call this position. Christ. Here, position here. Okay, this is better. So first of all, our we are going to look through the array with binary search, and we know with binary search we use 2 pointers, left and then right. We find the midpoint by just summing up these values and dividing it by 2. So this is going to be left plus right divided by 2. 0 1 2 3. So this is 3 divided by 2, because this is already 0, so I don't need to do that. So this is 3 divided by 2, and this is going to be 1, right? So our midpoint is at index 1, which is here, right? Which is here. I'll put mid here, mid like this. Let me use a different color. So this is our midpoint that we found here. So this is 1. Our midpoint is equal to 1, right? Our midpoint is 1. And yes, so item at position 1 here is 3. Now we know 3 is superior to 2. Now with a binary search where we are performing, where we find a value at the midpoint and that value is superior to our target, we move our right pointer down, right? We move the right pointer towards the lower values, right? So this is going to be here. So we need to move it 1 past the midpoint. So, or the midpoint minus 1, which is going to be equal to 0, because the midpoint here, right, the midpoint here, mid is equal to 1, and if we do mid minus 1, this is going to be equal to 0, right? So we have 0 as our current as the position where our right pointer has to move to. Now here's what one interesting thing that happens. So we calculate this again, right? We calculate the midpoint at this position. So we'll do this again. So we'll say left plus right, which is simply 0 plus 0 divided by 2. This is simply going to be equal to 0, right? This is simply going to be equal to 0, and we know 0, right? I mean, even though our left and right pointers are the same position, we don't stop the iteration yet. It's only when the left pointer, right, is now superior to the right pointer, then we will stop iterating, which is what the binary search loop is, right? That's the only condition we need to stop a binary search. So even though the left and right pointer are the same position, when we calculate the midpoint at this position, this is still going to be equal to 0. So our midpoint here is still going to be equal to 0. Now, since 0 is our midpoint, what do we do here? So we simply need to find the value at 0. Now the value at 0 here, right, this is going to be equal to 1. Now we know 1, this is the value at 0, at position 0, right? This is index 0 here. So we know when we find a value, right, so the midpoint here is 1, right? So we know 1 is less than our target, which is 2, right? 2 here. 1 is less than 2. So when we find a value which is less than the target, we move the left pointer past the midpoint, right? So let me remove this midpoint here. The current midpoint we have is here. It's going to be here. This is our midpoint here. So we move the left pointer one position past the midpoint. So the left pointer will be here, right? The left pointer will be at this position here. And our since we moved, this is going to be equal to 1, right? And this is equal to 0. So this condition is no longer valid for us to continue searching, right? For us to continue performing our binary search. So since it's past this position, so we stop the binary search. Now we did not find our target, right? And our binary search has ended. So we need to return the value at which our target would have been if it were inserted in this array here. So we simply need to return the left pointer, right? Because the left pointer will be at that position where we would have found this value, which is going to be at position 1 here, right? In other words, the index at which the left pointer is, which is equal to 1. So again, when you look at this, right, the reason why that is correct, if we had 0 here, right, and 3 was here, right, 5, 6 like this, 2 would have been in the middle here, right? 2 would have been in the middle, or in other words, 2 would have been the second item in the array if it were inserted in this array. And that's how we find the value at that position. So yeah, and that's it. That's all we need to do. So here's the solution. Hold on. No, this is not it. Let me close this. Yeah, so this is the question and this is the solution, and I did this yesterday. So that's it. I've covered both questions from yesterday, and yeah, that's all we need to do. So I have some questions. Hey, Ransom is my friend. All right, so Ransom said, did you read some books on Python? Not really. I didn't read any book on Python. In fact, dabbling around Python. I don't use Python for work. I've not used Python, for any uh intensively. Let me put it that way. I don't use Python on my day-to-day programming activities. I just use it for data structures and algorithm. But in the past, I've used it for some very simple stuff. Well, you can I think I learned it from a couple of websites. Yes, so I didn't read any book on Python. Um, Brother, where did you learn? Where did you learn DSA? Okay, I am still learning DSA right now. I'm still learning DSA, and I am still, solving DSA questions. So I'm just. This is why I did the 100 days of DSA videos, this stream, to show what I learn every day. So anything I learn in a day, I come here and stream it. So I'm still learning, but you can look at websites like so recently I found out about this website. It is called there's a YouTube channel. Let me find the YouTube channel for you guys. I think it is, hold on. There's a channel where they do LEETCODE competition. I'm not. Let me find where they do LEETCODE competition. Let me find the name of the channel. I'll get it for you now. So what's the? It's called Wes Wex LEETCODE. I mean DSA competition, right? Oh, I found the channel some time ago. I don't know why I did not subscribe to it. Let me see. Hold on. I need to find this channel back. I need to get it back and share it with you guys. They have so much resources, and the channel is very entertaining if you're into data structures and algorithm, right? So, Hack Success. It's called Hack Success. I'll share the link here in the description. Very good channel. Very good channel. So I'll paste the link here. Let me paste the link here. Now on their website, they have very a lot of DSA related. Yes, so this is this website. This is their page. So I like it. I watch some of their competition. It is very, very entertaining. So when you look at this, so let me drop the link in the description. I hope I'm allowed to do this. Hopefully they don't. I'm not stealing their content. I'm just sharing. I'll put useful resources. Useful resources. Resources here. Right. Now this is a very nice channel that I recently found out about, and yeah, I've been looking at this. You can go to their website, right? On their website they also have links for useful resources, right? When you scroll down, sorry, when you go to hold on, about, I think it's in about, was it about? It's a very good channel if you're interested in data structures and algorithm. You can learn a lot from this channel, right? Uh, Let me see. I'm not sure why. I found. I found. Hold on. I found the link to some of their resources. I'm not sure where it is. I'm not sure. Uh, I think here. Lit Coding. They have a list of resources, even some books on it. Just come to the website and look around. You will find very interesting stuff. Yeah, thank you. Love from India. Thank you very much, Rajat. Yes, thank you for showing up. Yeah, so these are some useful link. You can see tech interview handbook. They have neat code on this, right? I also have a neat code account. You guys should check out neat code. Very cool guy. I I really appreciate neat code a lot. Hopefully, you know, I get to speak to him one day. All right. So yeah. So this is where you can find some resources and some motivational stuff to push yourself and study data structures and algorithm. Yeah. So let's continue with our next question. Our next question would be on let me see. By the time I found out about Hack Success, they had just like 400 subscribers. Now they're at 10,000. Wow. Massive upgrade. Massive upgrade. This is really cool. Okay, so let's take a look at the next question. So the next thing I want to do is you see this two sum question. Very interesting question. And I want to use a binary search on it, right? Because I saw it was tagged. So I was scrolling through my binary search list, right? And I found out two sum was there, right? Although two sum I used, a simple I'm not going to say simple. I used a two pointer uh operation on this question in order for me to solve it. But since it is on the list of binary search, why don't we try it out, right? Try using binary search on it to solve this question. This is going to be very, very good. Now, here's what we need to do. So this will even help us enforce or you know memorize binary search properly, so that when we see questions like this, even though we don't know where what we can use to solve it, right, we can still just come up with a solution. So let's see how we can perform a binary search to solve this question. Now, here's what we need to do. First of all, we need to let's read this again. So given a one indexed array, there is no one indexed array for your information, FYI. But this is just to cause confusion. I don't know why they do this, but anyway, it's good. So given a one indexed array of integers numbers, right? Given a one indexed array of integers numbers that is already sorted in non-decreasing order, find two numbers such that they add up to a specific target number. Let these two numbers be numbers at index 1 and numbers at index 2, where 1 is less or equal to index 1, right? And 2 is less or equal to the numbers dot length. Now they are simply saying the index will be returning in this from. Let me just finish the question and explain what that is. So return the indexes of the two numbers, index 1 and index 2, added by 1 as an integer array, right? Index 1 and index 2. So there is nothing like an array, a one index array. All arrays are 0 index, which means we start counting from 0. So at the end of the day, what we need to do is wherever we found those two values, such that when they add them up, when they are added together, or when they are summed up together, they are equal to the targets. We just add 1 to those indexes, right? We do +1 +1. So the tests are generated such that there's exactly one solution. You may not use the same element twice. Okay. So your solution must use only constant extra space. Yeah, constant extra space. So which is returning this array here, because we are returning an array of indexes, right, at the end of the day. So here is the two pointers problem, right? I mean two pointers solution. If you look at the topics here, you can see it has two pointers with it. It has binary search and it has arrays. So I mean, when we use the two pointers method to solve this question, this is what we'll do. So simply we set the left and right pointers to the beginning and end of the array, and then we'll add those two values at those positions to see whether, you know, they add up to the target, right? So if they don't add up and the answer is, the result is superior to the target, we move the right pointer towards the left. Since the array is sorted, we move the right pointer towards you know, the lower values, right, in the array. And you know, when the result is less than the target, we move the left pointer towards the higher values until we get to a point where this result here is actually equal to the target, and we return the target value, right? We return the left and right there, right, at this position here. Now I'm not sure if I should explain that again. uh, so let me see. I'll just go. Let me go over it again. So let me copy this array here. Our target is 9, right? So we are going to use 2 pointers. Okay. So let's come here. I'll erase everything I have on the board and use 2 pointers here. So here, this is our 2. This is our array. I'll change this to white. Yes. Okay. So here's what we need to do. We'll use hold on, is he target? Sorry, I was done with this, right? Let me close these. Everything that I'm done with, I'll close. So here we have so our target is 9. Okay, our target is 9. Right. Okay, so our target is 9. So T for targets, T is going to be equal to 9. All right. So how do we? Your computer is running low on storage. What? This is not fair. I know why. Anyways, okay. So that's not important now. We'll do that later. So here's what we need to do. We start with it with 2 pointers, right? A left. Oh God. I'll put a left and right pointer here like this. Now we'll calculate, we'll do the result here is simply going to be equal to the value at the left pointer. So let's say this is x, right? Always x. So x at L, right, plus x at R, right? X at L plus x at R. This is simply equal to x. Where is R, right? Where is L right now? L is at index 0, R is at index, this is 0, 1, 2, 3. So index 3, right? R is at index 3. So we do value at index 0, which is 2, plus value at index 3, which is 15, right? 15. This is going to be equal to 17. Now we know 17 is superior to our target, right? So when we find a value that is superior to our target, we simply move our right pointer towards the left, towards the lower values, right, in order for us to get our target. So here is what we need to do. We move this towards this part here, and then we perform this calculation again. Now this time around, the values are not going to be the same, right? So we simply need to do this. We simply take the left, right, index 0. So this is going to be 2 plus 11, right? This is equal to 13, right? So 13 is still superior to our target. So we move the right pointer towards the smaller values, which is the this position here. So and we perform this calculation again. We calculate again, right? Let me erase this. We calculate again. So we'll simply do 2 plus this value here, right? 7 which is equal to 9. And then 9, we know 9 is equal to our target. So yeah, we found 9 here, right? And then we simply need to return the values at this position, which is going to be, left plus 1. We found these values at left and right, but the question says, the question says return the indexes of the two numbers, index 1 and index 2, added by 1, right? So we want to add 1 to those indexes. So this is simply going to be equal to left plus 1. This is going to be, I'll say return 1. Left plus 1 is going to be equal to 1, because left is at index 0 and right is at index 1. So this is going to be 1 and then 2, right? So when you look at the results here, you can see this is 1 and 2. Now, how can we use binary search to, calculate this, right? This is very interesting. So I will erase everything and keep the array and our target. Our target is 9, and the array is this. So this is our target. T is equal to 9. Now, how do we use binary search to perform this? Now, a simple calculation is, we know we need two values, right? Let me say x and y. X plus y has to be equal to t. Now, x could be any value in this array, but we don't know y. So let's say we know x. We can assume the first value here could be x, right? X could be equal to 2. X could be 7. X could be 1. X could be 15. But which other value can we add x to get to t, right? We don't know. So we can say, okay, y is simply going to be equal to t minus x, right? This is a simple equation to find the second value to which we can add x to get to t, right? Now, when we simplify things like this, we'll get a binary search question, right? Whereby the y value now will be the value we are going to look at. Y will become our new target. Our target is no longer t. We don't need t per se, because we've already used t to find the next value, the y value, right? So we need to find y within where y is within this array, right? In fact, let's say for instance we did this. We did y is equal to, so let's say here, right, this is 2, right? So t is equal to 9 minus 2, right? I said any value within this array could be x, right? It could be anything. So we need to find y. So if we did this, right, y could be equal to 7, right? When we perform this calculation, y is equal to 7. But where is 7 in this array? We can use a binary search to find 7 in this array. So we simply need to take, so our first value here is going to be I at index 0. So we then use a binary search to find the remaining value, right? To find the this 7. So y becomes our new target. So here's what we need to do. We simply take this 7 becomes our target. We put our left and right pointers, so the left pointer has to start one more than this position, or 1 plus the I here, because we don't want to duplicate. So we need to start from here all the way to this point here, right? So this will be our left and right pointer, and we will search within this range, right? Within this range for our next y value. And yeah, so when we get that value, it will simply point at a particular index or at a particular midpoint, right? Midpoint. And then when we get that value on it with the I value here, so meaning we will use two loops, right? The first loop will select our x values for us, right? It's going to be anything within this array. We can start with the first value and then look into the remaining values by performing a binary search to find the position where y is in this array. And yeah, so that's how we can use a binary search to find the solution to this question. So To do that, I will simply come here, right? This is question, sorry. So this is question 167 2 sum 2. So I'll create a new folder in the binary search, a new file in the binary search folder, and find the value at that point. So I'll say here Python file leet dash, oh sorry, leet dash 2, was it 167 167 2 sum, so 167 dash 2 sum, sorry, 2 sum 2. Okay, right. So let's do this. So first of all, I'll copy, you know, the boilerplate of this code here. You know what, let me copy. I don't know how to get to that point here, so I'll just copy everything. I'll remove these, we don't need those, and I'll just import this class, this type here. So it's a list, so we can type and access every value on this numbers array. Okay, so now we have our numbers array. So I said I'll use a left and right, X and Y. So X will be our first index, and Y will be the second value, right? So I'll say I'll use a for loop to get the X values for X in range. So let me just say, yeah, I need the index. So I'll say for I in range length of the numbers array, right? The numbers array. Here's what I need to do. I will say let's first of all find X. X is going to be, numbers at here at I, right? That is X. I said Y would be equal to I just want to use this to make it simple to understand. When somebody looks at this, the person will know what is happening here. So I'll say numbers at I, so Y is going to be equal to the target minus the X value here, right? Now we are going to look for Y by performing a binary search. So here's what we need to do. Binary search is simply left and right, right? So our left pointer is going to be at index, let me just put left right is equal to, so the left will start at I, right? I plus 1, right? And then the right is simply going to be equal to, sorry, the length. Okay, let me put them separately so that it's easy to understand. So left is going to be at I plus 1, and right is simply going to be at index, length of the numbers array, length of the numbers array minus 1, right? The last item. Now, so let's perform our binary search. So we'll say while left is less or equal to the right, then we'll say let's find the midpoint, right? The midpoint is going to be equal to left plus right divided by 2 rounded to the nearest 0 value. And so that's all we need to do. So we'll compare the values at each time, right? So we'll say if numbers at midpoint, right, at midpoint is superior to the right, is superior to the target, now this is wrong. This is no longer going to be the target. It's going to be equal to Y, right? Because we are looking for Y this time around. If this is superior to Y, then we will move our right pointer to the to the lowest values, right, to the left. So this is going to be midpoint minus 1. Otherwise, else if numbers at index at midpoint here is less than y, right, we are going to move the left pointer towards the right, right. We are going to move it towards the right. Sorry, it's going to be equal to the midpoint plus 1. Otherwise, meaning when we find the value at this particular midpoint, when the value at the midpoint is equal to the y, we simply need to return, let's just return the I plus 1, since we are going to return the values at that way. So I plus 1 and mid plus 1 here. So that's all we need to do. And in the case where we don't find any values, I don't think we need to return anything at all. I mean, it will be good to return an empty array, right? So let's just say we return an empty array like this. So here's all we need to do to, so I'll just copy this and paste this in LEETCODE to see what the outcome will be. I'm sure the space complexity will be a bit higher, but and the term complexity as well. But let's keep the fingers crossed. So let's run this and see what happens. Now it's taking longer time to result, but you can see it's 27 milliseconds. So let's submit this and see what goes on. Terrible runtime. This is, but the point is, this works, right? But the memory was just really bad. I mean, good, but I think okay. Let me try and improve this a bit. Instead of copying numbers here, right, I can just say numbers will be this x, and let's just do this. We can even take this away. The y, I'm just trying to reduce. I mean, because we are performing a binary search, which is O log n time complexity, and then we are performing it within a this, what do you call this, O of n time complexity, like O of n times O log of n, I don't know, O log of n squared maybe, which is why this is really bad. So here's what we need to do. Let me see if I can optimize this a little. Now if the I value we find here is not within this range, I can simply continue to the next value, right? So let's say if we get this target, right? So let's say if y is within, okay, so I can choose the left and right first. So say left and right. So if the crikey. So if left is less or equal to y, which is our target, right? This is our target, and this is less or equal to the value here, which is going to be what? I mean, this is never going to help y, right? But let's do it anyway. So this is going to be right. This is going to be right. I'm just showing how you can use binary set to perform this operation. I mean, it's not going to change anything at all, but it's good to try things out. So if this is, then we can do this. Otherwise, we'll continue the loop. Else, Let's continue. This is very funny. This is very funny. You just try hard to convince, you um so only when the y value is within this range. Of course it's going. Wait, this does not make sense at all. Mm-mm-mm-mm-mm. I mean, it's going to be right. It's always going to be. It is always going to be within this range. This is not going to change anything at all. It's always going to be within this range. So there's no point. There's no. Oh, sorry. There's no point doing this. I mean, we have 5.09 now. Let's see whether that's anything. Oh, wrong answer. You see, why is it wrong answer? Because of this. This was not smart at all. It wasn't smart at all. There was no need for this because the y value is always going to be between the remaining values, right? Between the left and right. So this is not going to work at all. I mean, target the output is 0 when we have 1 and 2. So let's see. Uh, uh, I mean, it works in terms of memory, but like, anyway, it's just for the sake of learning and understanding how we can use binary search. So it's not a lost knowledge. It's still good to know how to do things like this. In my opinion, yeah, just try things out. So possible. Uh, I think this will be our. I'll put a comment. New target. Sorry, new target like this, and this is going to be. This is going to be possible. New target possible. Possible first value or first, yeah, possible first value. New target and possible no, new target, the new target and yeah, possible sorry, possible second value. Possible second value. Yep. So, oh, um, okay. Thanks for to the people in Ghana. Oh my God, it's a love from Ghana. Ah, nice, nice to have you in the stream, Kofi. Yeah. Okay. So, so let's move on to the um to the next question. Oh my God, this is really funny. Okay, so the next question will be. Let me close this. Oh, I hated this question. This zigzag problem is so. I'm not. I don't know why. The we we try to keep questions to the highest quality. This question is. It should probably be the most. Let me remove it. Let me remove it. It should probably be the most disliked question on LeetCode. I don't know why they removed seeing how many dislikes a question has received, right? I don't know why they do that, but it would be so nice if we can actually see that this question is probably the most disliked question ever. Okay, so um let's see how we can solve this question. So here is it. The description sucks. So the string PayPal is hiring, right, is written in a zigzag pattern on a given number of rows like this. You may want to display this pattern in a fixed font for better legibility. And that's all. That is all. So this is an explanation. So here is the number of rows and we scatter we write the string in this exact form, and then read line by line, right? So, when you scatter the string, you just add them row by row like this, right? I think, yeah. So that's all. Write the code that will take the string and make this conversion, giving it a number of rows. So that's all. No explanation whatsoever. So here is an example, right? They'll give you paper is hiring and number of rows. So scatter this this string on a given number of rows. What does that even mean? No, you don't even know. Alright, so it's only strings. And I read through this. so but there was a question, there was an explanation that was quite helpful, right? So in this question, we need to convert the string in zigzag pattern. That is, have a 2D array with row n, right, and no limit of columns, and write the given string in this format. First, go from top to bottom, writing each character, and then go to the next column, but one above row until you reach the top row, and then follow this pattern repeatedly. So basically, you go from this point from top to bottom, and then one past the last item, the last row, and into the second column, back upwards, right? So let me also use another simple analogy to explain this. And for your information, I actually spent about an hour trying to understand this question. Yes, I did. So, which is why everybody needs to calm down. We're all learning. It's just learning phase, right? Don't feel bad at all. So for me to be here to explain this actually took me an hour to understand. So let's say, for instance, right? So here is our string. Our string is how many hours do I have left? Oh my god, my tab is even up. Oh wow. So I'll just come back here. Let me set this time to like 15 minutes. I don't know. I don't have 15 minutes, but I'll set it to 15 minutes. So I might just need to explain this again. And yeah. So let's see how it goes. Let's see how it goes. Oh my god, this comment is cracking me up. Love from Ghana. Yeah. Okay. So here we have a string s, right? Let's call this PayPal is hiring. Anyways, I think somebody said something funny here. Ironically, PayPal is laying off, which is really funny. Anyways, okay, so PayPal is hiring is our string, our input, and we want to return this string in a zigzag form. So, I mean, this question would have been simple. So let's say we're given like containers, right, to distribute these strings in it. So let's say our rows will represent how many containers we want to distribute the characters in, right? So I'll put, so how many containers were here, so how many rows do they want us to in so the number of rows will be 3. So just imagine this here, right, these rows as a container. So we'll have the first one, we'll have a second one, and we'll have a third, right, like this. Now we want to distribute each one of these characters into these rows, right? So this will be row 1, row 2, and then row 3. So how do we perform this distribution? Well, just imagine it this way. So let's say we put the first character here, P, the second one here, A, and then the third one here, right? PayPal, like this, Y. Oh, so this pay, okay, PayPal. Let me use a different color, not to mix things up. I don't know why my box is not really beautiful the way I wanted it to be. So I'll see. Let me draw. Are there shapes in this thing? I don't know. Is this circle? Oh, Christ. I don't want a circle. You know what? I'll just use I'll say I'll have it like this. So one line like this, one line, two line, and the third line. So we want to distribute each one of these characters on these lines by just moving in a single straight line, right? We're just going to distribute forward and then backwards, forward and backwards, forward and backwards. So here's what we need to do. So we'll take the first string, right? The first character in the string P here, right? So we'll put it in the first line, or I'll put it here like this. Or let me put it like this: P here, right? We'll have P, and then you know what? I think I should do it this way. I should represent it like this. I should represent the rows with a straight line, right? So we'll have, one here, one row, second row, and a third row like this. So we'll put P here, right? P will be here, which is the first character in the string, right? The second one will come here, and then the third one will come here. Now we'll have to. It's like we're spraying into buckets, right? Oh, I think I should use the bucket again. Okay, let's use the buckets. Let's use the buckets. So I will say we have containers like this, or buckets, whatever we could call them, and we want to distribute these values into these three buckets. Now these buckets will represent the rows that we have in the string, right? So let's say we put a P here. This will be P, and then we put this one A here, and then Y here like this. Now we'll have to go. I mean, when we reach the end here, we need to continue distributing, right? So we start the second distribution from the second. I mean, here we are at this position now, right? This is the fourth character, so we put it here like this. We put the P here, and then we put an A here, right? And then we go back again. We put the L here, and then we put our I here, right? And then we go back again. It's like we are distributing the characters within three containers, right? Into three containers, just by moving back and forth each time. So we are moving back and forth. So when we reach the last item, we need to insert into the second one, or the one before the last, and then when we are at the beginning, we insert to the second, and so on, right? So when we represent this in a straight, let me put my columns like this. I'll put it here. So we have P here, we have A here, and then we have Y here, right? So in the second, for the third item, we'll put it here like this. We'll put another P here, right? We'll put the P here, and then we'll have to add another value here. So we'll add an A here like this, and then we'll add again the L, and then the what else, Li, and so on, right? We'll do this until we reach the end of the string. So, or a better way to do this is to just say, okay, here we put our PayPal, right? PayPal, and then we start here again. We'll add, this is here with pay, yeah. So L will be here, then we'll go back up here, I will be here, and then S will come down to this H here, and then HI, right? And then we'll move to this point again. HI will go back up, so HI R I, right? And then we'll start from here N, and then we'll end here G. Now we'll now add each row, right? Each row, and then so it will turn into P S I A P A I H R N Y L I N G. So we scatter the string, right? P Y R. Sorry, maybe I must have mistaken the direction in which we add the remaining string. So PayPal. This is funny. There's no way I'm actually still thinking about this after spending so much time understanding it. But think about it this way, right? Let's say we have three buckets. Our buckets represent the rows, right? Oh, come on. Our buckets represent how many rows we have in our array. Let me check the comment section. Okay, so 3 watching. Good, good, good. So let's say our buckets represent where we want to distribute the values or the characters that we have in the string, right? So we have here bucket 1, bucket 2, bucket 3. So we make the distribution this way. Oh god, my bucket 1, bucket 2, and then bucket 3, right? So we distribute each character. So we put P A L, right? PAL, right? Oh, sorry, P A Y, PayPal, right? P A Y, and then the second one gets the next value, right? This is going to be P, and then we have A here, right? And then P again, right? I mean P L here, the third container, I, right? And then S, and then H here. Then we move to this part again, H I, then we put R here, right? We put R here, and I again here, N, and G, like this. So let's see. Pin. Wait. Hold on. That was, I think, oh my god. You know what? There's supposed to be, a distribution of characters in each row, right? Now, the number of columns we'll have is not really known at this point, right? Because we need to go down and then start distributing. We distribute into each row. Let's say we have the rows like this. I'll create an array, right? Let's say this array exists in a matrix, right? So this is our first array, this is a second array, and this is a third array. Okay, now we insert the first value into the here, right? And we insert the second one here, the third one here, right? Sorry, which is pay y here, like this. So when you look at this, you can see we have, oh, this is 4 rows. I was looking at something else. Hold on. Yeah, so we have, in this case, let's look at this case here, right? Which is PayPal here. Okay, so when you look at this, right, the first 3 characters occupy the first 3 rows, which is okay. Now the second character, I mean the fourth character in the string, where would it go? It will go to the middle row, right? It will go into the middle row, which is Y here, right? Oh, sorry, which is P here, this P here. Okay, so we have P here, and the third value, right, since we are shifting towards the right, so we'll just give it a little space, right? We'll come here, right? So this is So let's do it this way. I'll put 0. Let me erase this. Christ, that's a very. So let me say 0, 1, 2, right? This is 0, 1, 2. So we added these values here. Now the fourth value, sorry, the character at the third index, right? We'll go here. We'll go to P. We'll come here, right? This is P here. Now this here, fourth one here, will come to this part here. So I'll put this here, A, like this, right? And in fact, we don't even need to. That spacing was just really confusing. We can just put it beside it, right? So this will be A here again, right? This is 4, and then the fifth one will start from here, right? So this will be L, right? And sixth one will come here. This will be I, right? And then we'll move back up again. 7, this will be S, right? S, and then H like this. Oh, I see why. I see why it was moving. But we can have H here like this, right? This I, this is 8, 9. So I can come here, and 10 will come here like this. 10 will be at this position. See, it's almost it's weird how I unknowingly moved the character from the. So we can just have I here, and then the 10th one here will be here, right? Will be here, and then 11th will come here, which is N, and then you will have G here like this, which is the 10th one. You can put your G here, right? So we combine each value on each row, right? We'll combine each value on each row. So this should be what this should be our final value. I'll copy this and see whether we'll get this. I don't know why I missed this R. Was this the R here? Oh, where's the R? I didn't even remember where to put the R. Oh God. Wait, I'll go back again and write it all over. I don't care how long it takes. I mean, the explanation. I mean, my time is up. Let me truly explain this. Let's go again. This should be what we will have in the end, right? I'll put this here. I'll just explain this, and I'll leave it for you guys to solve this. Although I've already solved this and I understand how it works. So we would create 3 rows, right? The number of rows we are given, we want to distribute this within 3 rows. You can see here we distribute this over 3 rows, right? This is 1, 2, 3 rows. So we want to do the same thing here. So we'll create 3 rows, right? And the number of rows we'll create will be given to us, which is num of rows, the second input of this question. So here we start with the first one, P A, and then we put Y here like this, P A Y. Now the second in the second iteration, I mean, sorry, for the fourth value, oh God, let me put this 0, 1, 2, right? So I'll do P A Y like this, and then here. Now, since I'm distributing from, up to bottom and then bottom to up, right? But I don't distribute in the same position twice. I start with the second one. So I'll move this P here. This will be 3. So I'll put this P here, and then A, which is 4. A will be here, right? And I'll come down again, which is fifth one. This is L, right? That's L, and then I here, 6. I will be here, right? This is 6. And then we will do the same thing. 7. S is 7, right? S, H, 8. So this is H, 8, right? And then we'll move 9 here. I, which is 9. And then 10, which is our R here. Okay. Then we'll do 11. 11 will be I here again, and then 12 is this n here, and then here we'll have 8g. We'll put the g here. So we'll combine 8 strings. So this row here will give us PAHN, right? This row will give us APLSIIG, and this row here will give us YIR, right? And then we'll combine row by row. So this will give us PAHN, APLSIIGYIR, right? So let's paste the answer here and see whether this is correct. We'll see whether this is correct. So we have PA, right? Oh, come on. I'll put this in white. So let's use this. You can see we have P and P, A and A, H and H, N and N, A and A, P and P, L and L, S and S, I and I here again, I here, G here, Y, I, and R here. Yeah. So that's how we'll solve this question. And I'll provide the solution tomorrow. My time is up. And I'll see you guys tomorrow. Thanks for watching and keep coding. Right.